If you stood on the cliffs of southern England in the summer of 1940, you wouldn't have seen very much. The channel looked calm enough, the sky deceptively empty. And yet, beyond the horizon, hundreds of enemy aircraft were already on their way. During the Second World War, my father was a radar technician. He would often talk about how radar was the country's secret weapon in winning the Battle of Britain. I thought that he was exaggerating a little. He wasn't. Britain didn't have the luxury of being surprised. Its very existence was at stake. What it needed was a way of listening to the sky. This is a story of world-changing invention, quiet genius, and one of the most astonishing intelligence failures of the Second World War. And it begins with a question that desperately needed to be answered. How do you defend a nation against an enemy that it cannot see? By the mid-1930s, Britain knew exactly what was coming. Across the Channel, Germany was building an air force on an industrial scale, and its fast, long-range bombers were only 90 minutes flying time from London. Throughout history, Britain had been protected by the sea. Now it was painfully exposed. There was always a quiet certainty that danger would have to cross the water first. Now, for the first time in history, Britain could be attacked from the air. You can imagine the shock of that realization, the sudden understanding that the old rules no longer applied. And as an island nation, there was nowhere to regroup and nowhere to fall back to. Defences relied on men with binoculars, sound detectors, and hope. If aircraft were spotted, it was usually when the bombs were already falling. The Royal Air Force faced an impossible dilemma. Keep fighters in the air constantly and exhaust pilots and machines, or wait and risk being too late. What Britain needed was time. And that meant seeing the enemy before the enemy saw them. And the answer was already in the air, hidden inside of radio waves. In the 1930s, Britain was worried. Rumours were flying that the Germans might be developing a terrifying new weapon, a death ray capable of zapping aircraft out of the sky. So the Air Ministry turned to Scottish radio expert Robert Watson-Watt and asked the big question: could radio waves be used as a death ray to destroy enemy aircraft? Watson-Watt and his assistant Arnold Wilkins ran the numbers and gave his verdict. Absolutely not. The power required would have been off the charts. But in the process, he realized something far more useful. Radio waves could bounce off planes and reveal their position long before they were visible. Transmit a pulse, wait for the echo, measure the delay. Suddenly, distance wasn't guesswork, it was mathematics. Within weeks, Watson-Watt demonstrated that aircraft could be detected miles away, long before they were visible. It wasn't pretty, and it wasn't precise, but it worked. And Britain, sensing the clock was ticking, made the critical decision to fund his project. What followed would change warfare forever, and it was built in full view of the enemy. By 1939, strange towers began to appear along Britain's coast. It had taken just 4 years from that first crude demonstration to construct the world's first integrated radar defence system. They marched along the shoreline in a loose chain, from Scotland down to the south coast. They called it Chain Home. Each station blasted powerful radio pulses into the sky, and aircraft reflected them back. Britain was ready. For the first time, it could see an attack before it began. But the tall steel frames were impossible to miss, and the Germans saw them too. They photographed them, they mapped them, they discussed them. And on the 3rd of August 1939, British radar technicians picked up an echo moving towards the Thames estuary. The echo was massive, bigger than anyone had ever seen before. They plotted the echo from the coast of Essex all the way up to the south of Scotland. It was a German airship packed with radio instruments, and they were combing the wavelengths listening for any sign of radar. At their command, the mood was grim. They feared that the very first bombing raid of the war would wipe out the entire radar system. But the initial bombing raid never came. It was one of the most confounding episodes of the war. German radar systems at the time were more advanced. They generated their own pulses at between 500 and 1000 times per second. British radar, by contrast, sampled pulses from the national grid. And at just 25 pulses per second, the only thing the German radio technicians heard was a dull ticking sound. This sounded nothing like their own radar systems. They concluded that it was just the arcing and sparking of Britain's national grid. Britain's primitive radar system allowed it to go undetected by the Germans. It was one of the biggest intelligence failures of the war. As a result, the towers were left standing. They were bombed occasionally, but never systematically destroyed. Britain's early warning system survived intact, and when the Luftwaffe finally came in force, Britain was waiting. What followed would decide the fate of an entire nation. During the Battle of Britain, radar didn't fire a single shot, but it conducted the entire defence. In the summer of 1940, chain home stations tracked enemy formations as they crossed the Channel. Hundreds of aircraft lifting from airfields in France and heading directly towards London. Inside darkened huts, young men and women stared at glowing screens, watching blips drift slowly across the glass. Those signals fed into central command rooms where plots were updated in real time and coloured markers were placed on enormous maps. For the first time in history, an air battle was being managed. I doubt that the observers had time to marvel at the technology before them, or to contemplate radar's impact on the future. For them, it was just a tool, helping them survive in the present. Radar gave the Royal Air Force precious minutes of warning, enough time to scramble fighters from multiple airfields and converge on the enemy. This convinced German planners that Britain's air force was much larger than it actually was. British pilots were often outnumbered, but again and again they inflicted devastating losses on the Luftwaffe. In many ways, the Battle of Britain had been won before it had even begun. Without radar, and without the system to make sense of it all, Britain almost certainly would have fallen. And without Britain, the war would have taken a very different path. But radar's story didn't end with victory. When the war ended, radar didn't fade away, it spread. What had begun as a closely guarded secret evolved at an extraordinary speed. Airborne radar allowed fighters to hunt bombers through cloud and darkness. At sea, radar revealed ships and submarines long before they could be seen. A new kind of battlefield had emerged, one defined not by territory but by signals and echoes. And then, almost without notice, radar slipped into everyday life. The echoes that once tracked enemy aircraft now keep passenger planes separated, trace hurricanes as they form out at sea, and guide ships through fog and darkness. And radar didn't just defend a nation, it trained a whole new generation of engineers. Because to make radar work, engineers had to master high-frequency electronics, signal processing, and the coordination of complex systems. And those skills became the foundation of the modern technological world. Telecommunications, satellites, GPS timing, and digital computing. Even the microwave oven traces its ancestry back to wartime radar research. What began as a desperate attempt to defend a nation in its darkest hour became a platform on which modern life was built. In 1940, radar answered a simple question: what is out there? Today, that isn't enough. The question now is, what does it all mean, and what do we do with it? Modern radar uses artificial intelligence to interpret what it sees, to tell the difference between birds and drones, weather and aircraft, noise and a threat. Instead of overwhelming operators, it filters, it learns, and adapts. Radar is no longer just detecting the world, it's understanding it. And that intelligence is moving radar into everyday life, into cars that look after us, sensing a child stepping into the road, a vehicle hidden by rain or glare, and braking a split second before we even realise there's danger. And into cities and buildings, helping emergency crews find people through smoke, dust and debris, detecting movement, even breathing, when seconds matter most. It carries forward the same quiet promise that it made in 1940, to give us time. It changed the course of history then, and in the future it may do so again. If you enjoy the stories of inventions, innovations, and the unsung heroes that shaped our world, please like and subscribe. It really helps people discover this channel. Stay curious, and I'll see you in the next episode of How the World Was Changed.